In this section, we're going to talk about the general power rule. And the general power rule works very similar to the simple power rule, except for one thing. The value here that's raised to a power is not just a single variable like x. It's actually a function. So this rule is used when you have a function raised to a power. But the trick is, you must have, with that function raised to a power, the rest of the factors in the integral must be du. So you've got to make sure that the integral will fit the form of u to the n du. And then if it will fit the form u to the n du, then all you have to do is apply the power rule and write it as u to the n plus 1 over n plus 1 plus a constant. Now, when you're calculating u to the n du, so when you're calculating this, like for instance, take a look at this integral here. This is actually one that will not work. So you have x squared minus 4 cubed. Okay, now if this is going to work, then the u would have to be the x squared minus 4. But if you look up here, you'll see that if I let u equal x squared minus 4, then du over dx would be 2x. So the derivative would be 2x. But now let's multiply both sides by dx, and you'll see that du has to be 2x dx. Well, do you see a 2x in this integral somewhere outside of this? No, all you see here is just this u cubed. So I don't have the 2x in here, so I can't make this in the right form because I won't have the du portion of it. Okay, now we'll see later that if it was just the 2 that I was missing, I can fix that. But when I'm missing the variable portion, the x, I can't fix that. So I'm going to start you out here. I'm going to show you 2 examples. One involves polynomials and one involves trig functions, and both of these work out perfectly. But we're going to find out that sometimes we'll have to manipulate them. But these 2 will work out perfectly. So when you're looking at this problem here, we're integrating 3x squared times x cubed plus 2 to the 4th power. Okay, well, you see this binomial here? This binomial is raised to the 4th power. So I'm thinking that I could think of this as u to the 4th power. And if I think of this as u to the 4th power, then what does the u have to be? Wouldn't it have to be the x cubed plus 2? So here set u equal to x cubed plus 2. Now remember what I told you up here. Du is simply the derivative of u times dx. So let's find the derivative of u. The derivative of u would just be 3x squared, and then we multiply that times dx. Okay, now you don't have to rearrange these terms, these factors, but I like to rearrange them in the beginning to show you. So I'm going to rearrange the 3x squared. I'm going to put it over here with the dx. So when I rearrange it, notice right here the 3x squared dx. Okay, now do you recognize that? That is exactly what we have for du here. So I can actually replace the 3x squared dx with the du. Okay, so you see I replaced it with du over there. And then remember this was u. So x cubed plus 2 was u. So I have u to the 4th du. And that's exactly the form I need in order to use this rule up here. So now that I have u to the n du, in this case u to the 4th du, I can apply the rule and I'll get u to the 5th over 5. So u to the 5th over 5, and then plus a constant. Now when you're evaluating these types of integrals, these are called indefinite integrals. If you have the numbers like you see here, those are definite integrals, but right now we're dealing with indefinite integrals. So when you're evaluating indefinite integrals, you always want to switch back to the original values. So before I finish, I want to replace this u with what I used for the substitution. So remember, what did u equal? U equaled x cubed plus 2. So let's replace it, and instead of u to the 5th, I'll get x cubed plus 2 to the 5th over 5 plus a constant. Okay, now let's take a look at this one over here. Over here, I have the cosine function squared. And so if I'm going to use the power rule, wouldn't it make sense that since I have this function raised to a power, wouldn't it make sense to let this function be u? So let's let u be this function cosine x. Now then du would have to be minus sine x dx, because du would be the derivative of cosine x, which is minus sine x, and then times dx. Okay, now again I'm going to rearrange these factors. So I put the minus sine x here with the dx, and now you can see that this is exactly the same as du. Du is minus sine x dx, so there's your du. And then since this is u, cosine x is u, this is just u squared. So now this takes the form u squared du. So if I'm integrating u squared du, I can apply the power rule and get u cubed over 3 plus a constant, and then replace u with cosine x, and that would be cosine of x quantity cubed over 3 plus a constant. Now, if I did not have this sine x in there, I wouldn't be able to integrate this the way I did. Just like if I didn't have this x squared up here, I wouldn't be able to integrate this as it is. Now, but the 3 or the negative 1, that's not a problem. I have ways to get around that problem. Okay, so I'll show you that in a few minutes. Now, so this is one power rule that we can use. This is called the general power rule. Now, there's also trig rules that we can use. Okay, so now look at these trig rules. All right, take a look here. In order to integrate cosine of u, where u is some function of x, du, I would have to have the du. So if u were some function of x, then everything else in the integral must represent du. And I'll show you an example of that in a minute. But if you can get an integral in the form of cosine u du, then it integrates to sine u plus a constant. If you can get an integral into the form of secant squared u du, then it integrates to tangent u plus a constant. Okay? If you can get it in the form of sine u du, it integrates to minus cosine u plus a constant. If you can get it in the form of secant u tangent u du, it integrates to secant u plus a constant. There's an extra u there that shouldn't be there right there. Just notice that. And then if you integrate cosecant squared u du, it's minus cotangent u plus a constant. And if you integrate cosecant u cotangent u, it's minus cosecant u plus a constant. Okay, so the trick is, can you get them into that form? All right, so let me show you an example here. So here I have 3x squared, and I have cosine of some function. So since I have cosine of some function, I might be able to get this into the form of cosine of u, where u is a function. All right, let's see if this will work. So if I'm going to try to get it in the form of cosine of u, then u would have to be x cubed plus 2. And then if u is x cubed plus 2, then du would be 3x squared dx. Okay, so if you'll notice, if you rearrange it, there's the du. 3x squared dx, that's the du. And then this is cosine u. So I end up with the integral of cosine u times du. So now that worked out perfectly. It's in the right form. So the integral of cosine u du is sine u plus a constant. And then replace u with the substitution x cubed plus 2. So this integrates to sine of x cubed plus 2 plus a constant. Okay, here's another one. Now here I have 2x times secant squared of x squared. Now you might think at first, oh well, why don't I think of this as the power rule since I've got a trig function squared, because I did that up there with cosine squared, but actually that won't work. What will work though, if you'll let u be this argument here, x squared. Okay, now watch what happens. If I let u equal x squared, then du would be the derivative of x squared, which is 2x times dx. So du would be 2x dx. Okay, now let's rearrange it. Let's put the 2x with the dx. And so we have the 2x dx right there. And guys, that's du. That's du. because du is 2x dx, so that's du. So now I have secant squared u du, and guess what? I have a formula for that. If you integrate secant squared u du, it's just tangent u plus a constant. So now that I've figured that out, that's secant squared u du, I can integrate this and make it tangent u. So that would be tangent u plus a constant, and then just replace u with x squared, and you got your answer. Tangent of x squared plus a constant is our answer. Now, let me just tell you one thing. Suppose this 3 wasn't here. Okay? Well, I could multiply the inside of this by 3 as long as I multiplied the outside by 1/3. So you can always multiply the inside of an integral by a number as long as you multiply the outside of the number by its reciprocal. So if this 3 had not been here, I would have just multiplied the inside by 3 and the outside by 1/3. Now in my final answer, I would have had 1/3 that would have had to come down here. So I would have had 1/3 times sine of u. And then here, if the 2 hadn't been there, I could have multiplied the inside by 2 and then multiplied the outside by 1/2. Likewise, like I just showed you. So let me show you on this one, and you'll actually see that on these next two. So on this one, I'm going to use a power rule. So here I've got x squared minus 1 to a power. So I'm going to use the power rule. So I'm going to let u equal x squared minus 1. Okay, then du would be the derivative of x squared minus 1, which is 2x times dx. Okay, now notice here I have a x dx, but I don't have a 2x dx. Okay, so how can I get a 2 in the integral? Well, why don't we just multiply the inside of the integral by 2 and then the outside of the integral by 1/2? Because see, multiplying by 1/2 and 2 doesn't change the value, because 1/2 times 2 is 1. So I'm allowed to do that. So multiply the inside by 2. But on the inside, the 2 is actually just to make this part match up with the du. So now the 2x dx is the du, and this is, of course, is u cubed. So I have 1/2. You have to now carry this 1/2 with us in every step. So I have 1/2, and then the x squared minus 1 cubed is the u cubed, and the 2x dx is the du. Now if I integrate u cubed using the power rule, I get u to the 4th over 4, but I have to multiply it by 1/2. So that's going to be u to the 4th over 8 plus a constant. Now replace u with x squared minus 1, and the answer is x squared minus 1 to the 4th over 8 plus a constant. So that's the little trick that we can do when we don't have the right factors in here. All right, here's another one. Now if you look at this, notice I see a secant times a tangent, and notice these arguments are the same. So let's just say for now that that's u. So this would be secant u, tangent u. Does that sound familiar? Well, let's take a look. Right here. Right here. Secant u, tangent u. That u is not supposed to be there. But anyway, integral of secant u, tangent u integrates to secant u. So I have a formula for secant u, tangent u if I can get this to work. Okay, so if this is going to be secant u, tangent u, then what's got to be the u? Wouldn't the u have to be x cubed? Sure, so the u has to be x cubed. So now let u equal x cubed, then du would be 3x squared dx. So now I need a 3 in here. So I need a 3 in here because I got x squared dx, but I don't have the 3x squared dx. So multiply the inside by 3 and the outside by 1/3, and then you've got 1/3, and this is going to be the 3x squared, and the dx is the du, and this is secant u, tangent u. So you end up with 1/3 times the integral secant u, tangent u, and then when you integrate that, you just get 1/3 times secant u plus a constant, and then when you integrate, when you replace u with x cubed, you get 1/3 secant of x cubed plus a constant. Okay, the next video I'm going to do is going to show you some integrals involving exponential and logs.